Okay, I think we're recording. There's a little bit of lag over there. So once again, welcome. We will continue with the next step of remembering. So every time I'm gonna try to give a very quick, what am I doing in here? So at this point, so the overall is redoing is a series of videos that I'm trying to do where I am replicating a methodology for a project, my master's project, which is focused on biodiversity conservation and area prioritization for biodiversity conservation. In the first two videos, I've been talking mostly about a little bit of the introduction of what, the last one I specifically talk about what was mostly done in the project, like what materials they would use to what kind of products did I end up having. So this is going to be, at this point, we're getting closer to see the materials for the species, which is going to be the class Amphibia, looking at the variables in the overall, like the area for calibration of the modeling, and which kind of variables we are going to be using. So very quickly, for variables, I'm talking about climatic information, which, so we can understand, I've mentioned them a little bit before. So from a starting maximum, minimum, and precipitation, we can calculate these 19 variables that are pretty well known and I think used. Hopefully not much has changed, but this is the type of variables that we will be working with. Now that does not mean for this particular project we did not use all the 19 variables. I also considered trying to use land use categories. So I'll go into that, because one of the important things was like we actually selected a specific set for each one of the species. That was like very important for this project, because usually they use all of them like a shotgun, and apparently there can be some redundancy of variables or variables that do not properly inform for a given species. Meaning, in this case, amphibians, yes, they tend to be more sensitive to climatic conditions, right? But for a species such as, like, let's say, a puma con color, a cougar, right, a puma, that is a species that can resist a lot of climatic changes. So it could be the same, like maybe the mean diurnal range or the maximum temperature of warmest month. It doesn't really matter to that species, right? So that's what we meant. Like we run an algorithm. I think it was GML. Yes, I think it was a GLM. To decide or to see which of those climatic information was more informative to the occurrences that we worked at a time for a given species. Maybe I will go into that, but I think it is pretty self-explanatory. Is which of these climatic information or land use categories were the most informative, and that way we will be using those to model each one of the species. Okay, so that's that. So in terms of files, yeah, this is basically all of them. Actually, this last one is the product of that calculation that I was talking about. I think I'm gonna have a hiccup. Yeah, I'm having very bad allergies right now, so hopefully that does not come into the video. Okay, so yeah, so I was saying that this first file is actually the final set. I think I have it open over here. So this is how it's going to look, right? I'll go into what I think there is another file where I'll see that each one of these v1, v2, v3, v blah 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 blah, which one of those represents the 19 variables. Okay, no, I think in the beginning we also try to include altitude, but because we are working with climatic change or time periods, altitude makes no sense. So at the end we end up removing. I think that's what it means over there. So we end up removing. We're not considering this guy. Maybe if that's the case, we will see that happening in the R script. But then we have the 19 variables and finally, yes, the 7 categories. So you see, so it's the 19 variables. So I think I already removed, and yes, I think I already removed altitude from this set. But all these zeros and ones, it's literally which, like the sets that for each one of the species. So we have 10 amphibians. So there's that, right? Now, so take a look at this. Like very few times we have some of the land uses. So from 27 variables, we have the lowest set, it's 8, and the highest is 10. At the same time, not all of them are selecting the same one, right? Let's see. I just want to know from all the variables if there are some of them that were absolutely not selected. So, well, some of them is they were selected at least once, yeah. So yeah, so we have some variables being more frequent than others. 8, 9, yeah. So 8 and 9. So this guy and this guy were the most frequently used. Let's just see what do they mean. So is that 2 and the 15, let's say. Mean diurnal range, interesting. So mean diurnal range, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 15, and precipitation seasonally. So this is important because at the end, this can be part of the argument of like, we work in amphibians and this is the type of variable that seems to be affecting more amphibians. I'm actually interested. Well, I mean, yeah, so after 8 we have 6, and for example for me this makes a lot of sense. The annual mean temperature, sure, and where this precipitation starts, 13. Okay, 12. So 12 is 4 times. So this is interesting. I really like, this is the type of things that can be actually discussed. Like, why would that happen, right? But anyway, so this is important to have because this is what will be used when we perform the modeling, right? I'm not going to save any of these changes. Well, actually, okay. So here it is, right? Again, I think for the actual sets of variables, I have already removed altitude, but this is what I meant, right? I had altitude over here, but in this case, it won't matter. And this is how the data actually looks like. Now, if you can see here, I have var, right? This is that file. Now, because this was a very heavy set, it was one of the biggest challenges that we encounter was the fact that we were trying to work with the best resolution of information, because each one of these lines, it is part of a grid, right? Because those were like raster files, and unfortunately for the variable selection, we needed to go from 1 kilometer, which is like very ideal resolution for this situation. We needed to upscale to 10 kilometers square. So var belongs to 10 kilometers square. I don't know if I have enough time. I think I'm going to be talking way too much about the variables, right? But then just here we have like one by one. So those were the ones that were used during the modeling. We will go through them like later on. The biggest difference between these files and the way that you can actually see how many lines they are, right? It's like one of the grids. So, well, okay, no, actually, no. I will go ahead and show now in a map, right? In a moment, right? So we can actually visualize this, right? This was the area for calibration and the area for variable selection. So all of that is what I was talking about, belongs to a 10 by 10, right? Now, once again, this is for calibration and for the variable selection. Once we are able to do that, we don't need to be working with full country, right? That means that for our 1 kilometer square, this is how the variables look like. Yeah, like again, the black points is this file var, and the red points are all of these guys. Like this is the actual area of study, because now we are able to actually work very deeply into this area in greater detail. My computer is a 7-year-old computer. This is what I have for now. And yeah, it was going to be impossible. I don't know what kind of computer would I need, you know, to be able to do the whole one by one for the whole country, right? But this is basically where we're working. So you can see the little dots, yeah. But yeah. And saying that, it is also important to know, to see like, why do we need to be considering the full country? Well, it's mostly because of this point, right? Each one of these points belong to one of the species that we work with. Like, even though there might be amphibians, there are some amphibians that tend to be more alerted to be endemic, and then other ones that we can find somewhere else. Like in this case, we have the biggest distribution, well, report for who you are. Who. So this is, oh my gosh, suitability belly. I'm butchering this thing. So anyway, but you can actually see that this is all the dispersal points, well, not dispersal point, location points that we were working for that. So we need to have a very big calibration area so we can gather as much climatic information as we can. And afterwards, we can go into more detail in the one by one. Bigger to acquire most of climatic information, smaller for more detail. I think I'm going to leave this video here so I can try to see. I think next one is going to be already like getting deep into the script. So yeah. So we'll see. This is yeah, I will just go ahead and open. I will go ahead and open in our studio, but I would love to try to do it in Visual Studio Code. I don't know if I'm capable of that. I'm very new using that one. Yeah, so yeah, I'm just going to open it. I'm going to leave it exactly there, and yeah, we'll continue. You know, I'll keep going into that until we finish. Let me open. Yes. Yep. So this is it. So I mean, the whole why do I use in Z? This is exactly the reason why. Because right now it was in F, and now I can do that, and yeah, that's something easy for me. So yes, I'm gonna leave the video here, and then we start going into the script. See how maybe we could test the variable selection at one by one. We'll see. Anyway, thank you, and hopefully you keep tagging along. Bye-bye.